Hi, welcome to my channel, JaberTime. Today I'm going to go over plot points on a rectangular coordinate system, graph a linear equation by plotting points, graph vertical and horizontal lines, find the x and y intercepts, and graph a line using the x and y intercept. To get started, we will start talking about the ordered pair. As you can see right here, we have the ordered pair x and y as it shows right here. This is x and y as ordered pair, and the first part is called x and the second part is called y. That's why they called it ordered pair. And we have quadrants: quadrant 1, quadrant 2, we go counterclockwise, and quadrant 3 and 4. We're going to talk about this more in just a few minutes. The origin is the point that we need to refer to right here in the center, where x is 0 and y is 0. This point is 1, 3, and 1, 3 is 1 for x and 3 for y. You go right 1 and you go up 3, and that's how you graph it. Okay? We're going to see more examples, so let's move on. In this case, I have points on the x-axis. To refer to them, I have 0, 4, which means 0 for x and 4 for y. You're not moving right, you're not moving left, and you are going only up 4 units. On the other hand, I have -2, 0, which says you move left 2 units and you don't go up or down. Okay? Next. This is an example. I want to show you enough examples. That's why I'm having enough slides instead of going over a few slides with a few minutes of a video. -5, 4, for example, is taking you to the left 5 units and 4 units up, as you could see. Okay? This is 5 over 2, which is 2.5, so that's a 3 and 2.5. 3 to the right and 2.5 up. As you can see, it's like right in the middle. 0, -1 means 0 for x and -1 for y. So you're not going right, you're not going left, you're going down 1 unit, as you could see right here. 2, -3 is going right 2 units and going down 3 units. Notice that this point has both negatives, -x and -y values, because you're going left 3 units and you're going down 4 units, so you should be in quadrant number 3. Quadrant number 3 talks about both negatives. And this is a summary of what I just mentioned. Quadrant 1 is always positive. Positive for x, positive for y. Quadrant 3 is left and down. That's both negatives. Quadrant 2 is to the left. That means x is negative. And to going up, that means y is positive. Finally, quadrant number 4, you'll go right and you'll go down. So x is positive and y is negative. Next. This is called standard form. Standard form for linear equation is of the form ax plus by equals c, which is written right here. And here's an example. When they say x plus 4y equals 8, that means a is 1 and b, which is the coefficient of y, which is 4, and the constant on the right side of the equal sign is 8. Just to compare and know what's A, what's B, what's C. To graph a linear equation on the form ax plus by equals c, every point on the line is a solution of the equation. Every solution of this equation is a point on this line. So what they're trying to say is, if you have a line that is graphed and is represented by ax plus by equals c, you have any point that belongs to it, belongs to the line, will fit right here, will make this true. And any point that will make this true will also fit on the line. That's what they're saying. Here's a graph of a slope-intercept form, which is y equals 2x minus 3. This is called y equals mx plus b. That's a slope, and this is the y-intercept. B is the y-intercept. The y-intercept is 3, as you could see. Negative 3. That's negative 3 for the y-intercept. And the slope is 2. The slope is 2, which means from any point, like this point here, which is clearly graphed for us, you go up to and over 1 to reach to another point. And you do the same all over the place. Up to, over 1, up to, over 1. Just to be clear, when you do it by hand and mark those points, then use the ruler to connect them. So if the slope is 2, we look at it as a fraction, which is rise over run, 2 over 1. The graph of y equals 2x minus 3 is shown for each ordered pair. Decide is the ordered pair a solution to the equation, and is it a point on the line? Well, 0, negative 3 is, I could see it right there. That's 0, negative 3. Let me use a different color. 0, negative 3 is this point right here. Okay, the y-intercept. How about 3, 3? To use 3, 3 or refer to 3, 3, I'm gonna go up right here. Do you see it? That's 3, 3. So yes, it does belong. How about 2, negative 3? Let's go for 2 and negative 3. 2 and negative 3. 2 and negative 3 is down here, and that doesn't belong. So 2, negative 3 does not belong, because 2, negative 3, if you're going to graph it, it's 2 to the right, down negative 3, and no, it doesn't belong to the line. Let's try something else. I will go with green to distinguish. The last one is negative 1 and negative 5. Graphically, negative 1 is here, and negative 5 is down here for the y, so it has to be there. It looks like, yes, it's right there. You see the graph? So this one is negative 1 for x and negative 5 for y. Okay? And this is the total work both ways. Looking at the graph, and algebraically, you just graph the points, plug in the points and see if it works. So algebraically, for example, 0, negative 3, we said it belongs, which is right there. You put 0 for x, you put negative 3 for y, and you test it to see if this is correct. 2 times 0 is 0, minus 3 will give you negative 3. Left side is negative 3, check, that's true. This one here that we said it doesn't belong, plug in 2 right here for x, you get 4. 2 times 2 is 4. 4 minus 3 is 4 minus 3 is 1. And 1 and negative 3 don't agree, so no, it does not belong. That's the only point that I said 2 and negative 3 does not belong, all right? Which is somewhere right here, okay? Somewhere right here. It's kind of hard to graph on the top of the line. So, are the points on the line? Plot the points 0, negative 3, 3, 3, 2, negative 3, and negative 1 and 5. I did that earlier on 2 slides before, so that shows exactly what we are talking about. 2, negative 3 does not belong. That's the only one that does not belong. And this is a summary of what I just said. One more time, I could skip that, but I want to show you enough details through the slide. You could slow down. You could hit the space bar. That will stop the video, so you could look at the notes or read what's down here. And hit the space bar again to move on. Use a graph of y equals 3x minus 1. For each order pair, decide is the order pair a solution. Let's pick one. Let's pick 2 and 5. Use graph. So I'm going to use a graph. Is the order pair a solution? Okay, 2 and 5. This is 2 and 5. 2 for x, 5 for y. If you want to use the equation y equals 3x minus 1, you want to do the following. You want to say question mark, because we don't know if it's going to be true. We are checking if this works. We put 2 for x, because that's what it says, minus 1, and 5 for y. 3 times 2 is 6. 6 minus 1 is 5. Exactly like what we expect on the left. So yes. Okay. More details to show you how to do it. It's right here. Okay. So when you have 0 for x, you get 1 for y. Let me go back and look at the order pairs. 0 for x and 1 for y. That's a different example. This one here is algebraically, and it says y equal, it's right there as you could see, y equals 2x plus 1. And to check with some numbers, to graph it, as you can see, graph a linear equation by plotting points. To plot points, to be on the safe side, you need 3 points. I know 2 points will determine a line, but if you make a mistake, you're not going to graph the line correctly. So you need 3 points. So a good choice here will be plug in 0 for x. That means finding the y-intercept. Well, if this is 0, 2 times 0 is 0 plus 1. So that's going to be 0 plus 1. Which is just 1. And that should be 1. And that's what they're saying. If x is 0, y is 1. And if you try x equals 1, as they say, you plug in 1 for x. 2 times 1 is 2 plus 1 is 3. So that's 3. And let's try in a different color. If you try for the last column, let's go up here, negative 2 for x, you plug it in. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. So now you have 3 points to be on the safe side. Now let's talk about graphing y equals negative 3x and y equals negative 3 and see what's the difference. Graphing y equals negative 3x, it's y equals negative 3x plus 0. So the y-intercept is 0, which is right there. And if you plot points, if you plug in 0, you get 0. 0 times negative 3 is 0. If you plug in negative 3, or let's say positive 1, just to stay consistent with what they have, 1 times negative 3 is negative 3, which is right there. So we get the 0, 0 and the 1, negative 3. 1, negative 3 is right here. And let's just use 2, just like they did. So if you plug in 2 here for x, 2 times negative 3 is negative 6, as you could see. 2 and negative 6 will be down right here. That's 2, negative 6. Okay, now When you go after y equals -3, this is a horizontal line leveled at y equals -3, which is down right here. You could plug in points. If you put 0, it's not going to change, -3. If you put 1, still -3. If you put 2 for x, it's not going to change. Y is always fixed to be -3. 0, -3. 1, -3. And 2, -3. And that should do it for this example. Next one. Graphing y equals half x plus 3. When you want to graph y equals half x plus 3 and you want to plug in points, good choices will be 0. Everything is written, guys. I just want to go over it. You could pause the video and read more if you want. But 0 times half is 0 plus 3 is 3. That is this one right here. Let's use a different color and plug in as they did 2. Now why 2? Why not 1? Because if you go half times x plus 3 and you put 2 here, 2 is going to cancel. That's why they picked 2. So if you have a fraction of half, you want to pick 2 and 4 and 8 so you could get rid of the half in your way. Half times 2 is 1. 1 plus 3 is 4. 1 plus 3 is 4. And that should do it. That's a 4. As you could see right here, 2 and 4. 2 and 4 is already graphed. You go right 2 and up 4 and that should do it. Let's take a different color. They picked 4 for x, and I told you the choice y. 4 is a good choice because it reduces or simplifies divide by 2 1, divide by 2 1, divide by 2 2, plus 3. So you have 2 plus 3, which is 5, and that is 4 and 5. 4 and 5 is up here, 4 to the right, and 5 up, and that should do it. Okay, now graph vertical and horizontal lines. Well, x equals -3, x equals -3, you go left 3 units and you stay right there, which is vertical line. Let's undo this one because it's covering the number, and this is what I have for you. All right, if you notice right here, if you plug in -3, if you plug in anything for x will be -3, and y doesn't matter. Y could be 1, could be 2, could be 3, could be 4, could be 5, could be 0, anything. So y can be anything because x is fixed to be -3. All right, so that's a vertical line. Horizontal line. Horizontal line. Y equals 4. Y equals 4. No matter what you pick for x, y is 4. So as you can see, y is 4, y is 4. This point is also y is 4. So the y-intercept is 4, and all the points, they do have a y-intercept of 4. When y is 4, you go up to 4 and you stay right there, and that's called a horizontal line. And this is a summary of what we have: vertical lines and horizontal lines. Vertical lines, they usually look like x equals a, and horizontal lines, usually you go up or down and you keep the y fixed, and the x-intercept and the y-intercept will be referring to a and b the same way. Now, graphing x equals 0 and y equals -1. I'll do that quick before I show you the detail. Let's go with x equals 2. And when you do x equals 2, you are graphing it this way. Without much detail, I'm going to show you the detail right here, down below. X equals 2, you go right 2, and you graph it, and you are done. You could plot in points, but they're always going to have 2, 4, x. Okay, so this point right here, for example, is 2 and 0. This point here up could be 2 and 1. This point down here could be 2 and -1. Let's look for the other point. The other point, or the other line, y equals -1. To graph it, all what you need to do to be on the safe side and save you some time, you just go down to -1 on y and you graph it. If you want more detail, I have the whole thing for you. This is going right for x equals 2 and make it vertical, and this is going down for y equals -1 and you keep it horizontal. So when y is fixed, it's horizontal. When x is fixed, it's vertical. What is the difference between y equals 4x and 4? Before I show you the detail, let me go over it kind of quick. I have let's say a quick x and y axis. Okay, just kind of quick. And if you want to graph, let's start with the easy one, y equals 4. So you go 1, 2, 3, 4, and you stay right there, and that is a horizontal line. That is y equals 4. If you want to graph y equals 4x, let's do that in green instead. Let's change this to green. 4x, if you plug in 0, you get 0. That's the origin. If you plug in 1, you get 4. And 1 for x will take you up to 4, so it's this line. Notice I used 2 points only because I'm confident enough to graph it correctly, but usually take my advice and plug in 3 points. Another good point would be -1. -1 right here times 4 will give you -4, so -1 will give you -4, and that would be this point. If you need more detail to read, here's more detail. Table and graph for both. Okay? One more time, you could pause the video by hitting the space bar, and hitting the space bar again will play it after you look at the details. Graph y equals -3x and y equals -3. That will be a good example, another example. So y equals -3x, and we have y equals -3, and we have kind of like a quick x and y axis. Okay, here's x and y axis, and let's keep it with the same colors. We're gonna go down. Let's graph the horizontal line. You go down to -3 and you graph it. That is referring to y equals -3. When you graph y equals -3x, you could plug in 0, you get 0, and one more time. And if you plug in -1, notice what happens. I have -3 times -1, which is +3, so the answer is 3. -1 will give you +3. -1 will give you a +3 somewhere up here. Okay, let's take 1. Doesn't hurt. Take 1. 1 times -3 is -3. So when x is 1, you have y equals -3, and now it looks like we did the math correctly, so it goes this way. If you need more detail, I have it right here. Okay, so that's the whole thing with the table and the graphs. Now we have find the x and y intercepts. The points where a line crosses the x-axis and the y-axis are called intercepts of the line. For example, if we focus on example number 1, which is part A, 2x plus y equals 6, 2x plus y equals 6. When you want to find the y-intercept, you need to keep in mind that x is 0. When you want to find the x-intercept, you need to keep in mind that y is 0. That's the main part. So here for part A, let's find the y-intercept. To find the y-intercept, where it crosses the y-axis, I told you that x has to be 0, correct? So you always want to think about y-intercept means x equals 0. It's kind of like the other way around. For the y-intercept, you put x equals 0. For the x-intercept, you put y equals 0. So to do that, I have 2x plus y equals 6. And when x is 0, this is gone. So y is 6, which means I end up with 0, 6. And the graph shows it right there. With the same problem, same exact problem, 2x plus y equals 6. First we found the y-intercept. Let's go for the x-intercept. To find the x-intercept, you need the y to be 0. And if the y is 0, this is gone. So now you have 2x plus 0 equals 6. You have 2x equals 6. Divide by 2, divide by 2. So x equals 3. Finally, the point is 0 for y and 3 for x. 0 for y, 3 for x. We are on part A, figure number A. 3 for x and 0 for y. Okay? And the other point that we found earlier, it's right here. And the same way you could practice and look at the second one. And the equation is given to you, as you can see right here. The equation is given to you as 3x minus 4y equals 12. And notice that they give you numbers that works evenly and nicely with the x and y intercept concept. Let me quickly go over it without writing too much detail and erasing the whole slide notes from it. Okay, one more time. 3x minus 4y equals 12. Notice 3 and 4 and 12. They kind of communicate quickly. If this is 3 and this is 7 and this is like 31, that's not going to be a good choice for x and y intercept graph. So when y is 0, this is gone. 3x equals 12, that means 3 times 4 equals 12, so x is 4. You see it? It's kind of quick. And that's how you do the other one. Alright? The other way, you cancel the x to find the y-intercept. Minus 4y will equal 12. Divide or think, negative 4 times what will give me 12? That's negative 3, which is down here. See, I kind of went over it, but without much writing. This is another example, but here they have a case that says, a special case that is this line. Let's look at the first one quick, then I'll come back to the second line, which is more interesting. X minus y equals 5. So when x minus y equals 5, I'm going to do it quick. I'm going to do two choices. X minus y equals 5. See, I'm repeating myself. To find the x-intercept, you cancel the y. So let me do that in different color without writing steps. Cancel the y. What's x? 5. See that? See that right here? Cancel the y, you get x equals 5. Now cancel the x. Minus y equals 5, so y equals negative 5. Right there. So by looking at it, you could just finish working and graphing. Now, as I said, let's come to the second one, which is more interesting. It's y equal, from down here, negative 2x. To me, it looks like y equal mx plus b, but b is 0, okay? Because it's not written, so b is 0. The y-intercept is 0, and that confirms. You see that? Without graphing it as x and y-intercept, this is what I have. If you want to find the x-intercept and y-intercept, you just need to, once you plug in 0 for x, and once you plug in 0 for y, but both ways, if x is 0, negative 2 times 0 is 0, so that's going to be 0. If y is 0, 0 equals negative 2 times what? Times also 0. So you don't have practically like 2 points as one for x-intercept, one for y-intercept. They are both actually the same point because it's the origin. For that, you need to find other points, plug them in, and graph, or use the concept of the slope by going down 2 over 1, down 2 over 1, down 2 over 1, and keep going. Okay, for example, let me show you this point, why it belongs. This point, I could read it as 2, negative 4. 2 and negative 4. Yeah, if you plug in 2 here, you get negative 4, because negative 2 times 2 is negative 4. That's another way to graph the line if the x and y intercept did not give you 2 points. It gave you like only the origin. This is a summary of what we have. Ordered pair, general form, the line crosses the x-axis at A, so the point is A comma 0. That's the x-intercept. For the y-intercept is 0b, which we covered that, and down here they tell you more about the x and y-intercept. Once you plug in 0 for y to find the x-intercept, once you plug in 0 for x to find the y-intercept. Find the x and y-intercepts on each graph shown. Well, here's the full detailed work, but to find the x and y-intercept on the graph shown, I could find it by looking at the points, because they gave me clear points. For this one here, the y-intercept is 0, 2, and the x-intercept is 4 and 0, and they are written for you right here. For this one here, the x-intercept, I'm saying x because I'm crossing the x-axis, is 2 comma 0, and for this one here, it's 0, the y-intercept is 0 comma negative 6, and they are mentioned right here. The last one, let's use a different color right here. The x-intercept is negative 5, 0, and the y-intercept is 0, negative 5. That's the y-intercept down here, which is, of course, you could see it down here. Okay, next. This is more summary, more detailed. To find the x-intercept, you set y equals 0. To find the y-intercept, you set x equals 0, and that should do it. Find the intercepts of 2x plus y equals 8. To find them, you set y equals 0, and if you do that, you get what? I'm gonna just talk quick before I move on and save you some time. To find the intercepts, to find the x-intercept, set y equals 0. So I have 2x equals 8, which means x equals 4. How long does it take? You see? Look at the numbers, 2 and 1 and 8. They communicate nicely. To find the x-intercept, to find the y-intercept, I mean, the y value, you set x equals 0. So if x equals 0, you end up with y equals 8, so that's 8. And that's what they are talking about right here in detail. And this is how you do it, exactly the way I say it. You put y equals 0, you put x equals 0, and that should do it. That's full detail work. we came up with those numbers 4 and 0 and 0 and 8. As simple as that. When you want to find the x-intercept, you cancel the y. When you want to find the y value, the y-intercept, you cancel the x. So the intercepts are the points 4, 0 and 0, 8. And this is a table to summarize your work. Graph a line using intercepts. Well, I have negative x plus 2y equals 6. And to do it quickly, I'll just show you something. Then I'll show you the detail if you want to read more detail. Minus x plus 2y equals 6. We're going to do it two different ways. To find the x-intercept, we set y equals 0. To find the y-intercept, we set x equals 0. I have the work to show you in detail, but I want to go over it a little bit before. So when x equals 0, let's start with this one. This part is gone. So I have 2y equals 6. This will give me 2y equals 6, which means y equals 3. On the other hand, when y equals 0, I have minus x plus nothing equals 6, because y cancelled. Divide by negative 1 or multiply by negative 1, x equals negative 6. And now I have them without too much detail. How do you graph it? Quick sketch, x and y axis. And to graph this, you just mark the points. I have 0 and 3. 0 and 3. 1, 2, 3 up here. And I have negative 6 for x and 0 for y. So farther, maybe here. Negative 6 for x and 0 for y. And you just connect them. Okay. That's quick work without writing too much. But this is the full detail work that relates to what I just did. Alright. It's already graphed. And if you notice right here, just to add to my comments, they say plot the 3 points. It's always good to find another point. This is the x-intercept work. This is the y-intercept work. Says find another solution to the equation. Plug in 2 for x, for example, and finish it. Y, just to be on the safe side. So now they have the negative 6, 0. They have the 0, 3, and they have the 2, 4. Okay. Here, it's just like a quick practice. How would you do this problem using the intercepts? I have x minus 2y equals 4. Let's find the x-intercept. It's quick and easy. Why? Because when y cancels, I could see it. When y is 0, this cancels right here. So I end up with 4 here. See how quick? So before we lose it, let's mark it 4 and 0 is right there. Now on the other hand, x minus 2y equals 4, and I want to find the y value, that means the x-intercept, so the y-intercept, I mean. Once you put 0 for y, once you put 0 for x, and that will cover both points, the x-intercept and the y-intercept. If x is 0, the first part is 0, so this is gone, which means I have 0 minus 2y equals 4, which means minus 2y equals 4. Divide by negative 2, divide by negative 2, or you end up with y equals negative 2. Because negative 2 times, if you want to double check, times negative 2 is positive 4. So when x is 0, y is negative 2. right here. And when you graph it, you just connect these points. But I want to double check with another point that I skipped, and I'll do that quick. All right. So let's think about another point. Another point will be, I have x minus 2y equals 4. Let's pick y equals 1. Takes a few seconds to think about a number, but you could try anything you want. If y equals 1, I have x minus 2 times 1 equals 4, which means x minus 2 equals 4. Add 2 to both sides, and I get x equals 6. So my ordered pair is 1 and 6. So this is 6. You go right 6 and up 1, which is right there. Okay? I think that should do it. Graph 4x minus 3y equals 12. Same concept. You cross the x value, you cross the y value, and you finish it. I have the work done here, but let me, while we are on this slide, kind of quickly support without reading all these details. Take a look. 4x minus 3y equals 12. I'm gonna go with a lighter color. Let's find the x value, so let's put 0 for y. Could you see it, guys? This cancels. So I have 4x equals 12. 4 times what equals 12? 4x equals 12. 4 times 3 equals 12. That's 3 comma 0, which is right here. Let's do it the other way around. So let's pick a different color. I have, let's say, 4x, one more time, 4x minus 3y equals 12. And if you want the y value, I'm going to set now x equals 0. That's the y-intercept. So 0 minus 3y equals 12. Negative 3y equals 12. Divide by negative 3. Divide by negative 3. And y equals negative 4. 0, negative 4 is down here. This is a summary. They picked another point, as you could see. And that was another point. I don't want to keep plugging points. I want to save some time, but yeah, it would be worth it to test it with another point. When the line passes through the origin, the x and y intercept are the same. We talked about this earlier. Here's a graph of y equals 5x. The slope is 5 and the y-intercept is 0. So it's going to go through the origin and it's going to go up 5 over 1. And that is the full detail. So instead of reading all that, I'll just want to support it by saying y equals 5x. If you try to find the x-intercept and y-intercept, plug in 0 for x, you get 0 for y. Okay, now on the other hand, I said it the other way. Plug in 0 for x, you get 0 for y. Plug in 0 for y, 0 equals 5 times what? Equals 0. So both ways, it's the origin. If you don't want to use the slope and y-intercept, you could just take it from y equals 5x and plot points. Plug in 1. 5 times 1 is 5, and that's right there. Plug in negative 1. Y equals 5x. Plug in negative 1. 5 times negative 1 is negative 5, and it's right there. So we have the origin, and we have two other points, and that should do it. It's kind of lengthy, but hopefully it was helpful, and I tried to show you the full detail from the textbook. This way you could verify and read if you want to stop the video and pause the video. But anyway, hopefully it was helpful, and we'll see another one coming soon today. Thank you.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.